Hello everyone. In our previous lesson, we have considered how we can find the gradient or the slope of a line. We've looked at what the gradient shows when we find them. For instance, when the gradient is negative, it determines that the slope of a line is moving in the direction from the positive to the negative side. And when it is positive, we know the direction that it is moving towards. My name is Nana Awedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that I can get all videos on time. In this lesson, we want to consider the area enclosed by graphs. We want to see how we can find the area that graphs that we draw that are enclosed, how we can find that area, right? So now let's look at how we can find the area enclosed by graphs. So basically, when we are determining the area enclosed by graphs, we realize that every graph, for instance, in this case, the graph y is equal to 2x, right, has enclosed an area between x is equal to 2, which we have the line here, and y is equal to 0. And we see that that area is that of a triangle, right? Specifically the right angle triangle. So we see a right angle triangle here. And we can see that the distance from the point here, or the origin here, to the length here is probably subtracting 2 minus 0, which gives us 2. Right, and the distance from the point here, which is 0, to the point here will be basically 4 minus 0, which is equal to 4. Now, since it's a right angle triangle, we know the formula for finding the area will be equal to half multiplying the base times the height, right? So we need to have an idea of how to find the area of shapes, because the shape here is a right angle triangle, and that is half multiplying the base times the height. Now we've seen that the base will be 2 units, so we have the area to be equal to half multiplying 2, which is the base, and then the height is 4 units, so multiplying 4, which is the height. So it means that we have the area to be equal to half multiplying 2 times 4, which is 8, and that gives us 4, right? So we call it 4, right, square units, because area is multiplied in square. So we have the area to be 4 square units. So to determine the area enclosed by a graph, ensure that you know the shape of the graph that the graph has formed, right? The shape that the graph has formed. In this case, it's formed a right angle triangle. Use the formula for finding the area of that shape, right? In this case, a right angle triangle, to be able to determine the area enclosed by the graph, right? So let's consider this. So to find the area of the graph, first we must be able to know the distance from A to B here, because with this shape, we see that we find that the shape is more of a trapezium, right? So we need to find the distance from A to B, which is probably B minus A. And then we find the distance from B to F of B, right? Which will also be from F of B minus B, right? And then we need to find the distance here, which is F of A minus A. Then we can basically apply the concepts of finding the area of a trapezium, which we know that area of a trapezium is equal to half the sum of the parallel sides. This time we can use A plus B multiplied by the height. So the area of the trapezium, using the formula, once we know the length from here, which is a parallel side, and then the length from this side as well, which is the height, we know the length from B to F of B, which is a parallel side, and then A to F of A, which is a parallel side. We'll be able to substitute that to be able to find the area of the graph. Let's consider an example in this case. So the example says that draw the graph of the linear equation 2x minus 3y is equal to 6, right? So that's a linear graph or a linear function using GeoGebra or by hand, and determine the area bounded by the graph, the x-axis, the y-axis, and y is equal to 4. So now let's look at how we can draw this graph. So first and foremost, we must be able to write out the equation. So the equation given here is 2x, right, minus 3y is equal to 6. And then we are also saying that this graph, right, or this equation is also bounded by the x-axis, the y-axis, and then y is equal to 4, right? Y is equal to 4. So when we take the equation 2x minus 3y is equal to 6, we can decide that we'll let x be 0. So let x be equal to 0. So we want to find coordinates on the graph, right? 2x minus 3y is equal to 6. So when x is equal to 0, it means that you are going to have 2 multiplying 0 minus 3y is equal to 6. So that implies that negative 3y will be equal to 6. Then we divide both sides by the coefficient of y, which is negative 3, this side by negative 3. And that implies that our y becomes equal to negative 2. Right, so it means that for here, the coordinates of points for x and y will be 0 and negative 2. So that is the coordinates for x and y. And then we can also say that let y be 0. So this time we want y to be 0. So let y be equal to 0. So once y is 0, when we substitute y, we are going to have 2x minus 3 multiplying 0 is equal to 6. So we are going to have 2x is equal to 6. We divide both sides by the coefficient of x, which is 2, And then in this case, we are going to have x to be equal to 3. So this point as well is going to be, the x point of this is going to be 3, and then the y point is 0. So we have our 2 points that we can use to draw the graph. We have our x-axis, we have our y-axis, and we have y is equal to 4. So in this case, if you have your graph sheet or you have a jotter, you can sketch it, right? So sketch it yourself. Or you could as well get a GeoGebra and put in the functions, each of the functions, and then you'll be able to look at how it forms. You should be able to do it yourself so that you are able to come out with what it looks like. So let's do it here as well, where we are going to consider it on the graph. So we have our graph here. We are going to have our x and our y-axis as the question is demanding. So we have our x-axis. Let me use this color for emphasis. So that is our y-axis. Then we have our x-axis on the other side. So let's put our x-axis here. Right. So it means that we are going to have to label the sides. So we would have, let's say, 2 centimeters to 1 unit. So right, let's assume that from here to here is 1 centimeter. This 2 centimeters. So this 2 centimeters to 1 unit. This is a positive side of x. So we have 1, we would have 2, we would have 3, we would have 4, we would have 5, we would have 6, 7, 8, 9. Let's add 1 and then let it be 10. Then this side is a positive of y. So we have 1, we have our 2, we have 3, we have 4, and then we have 5. Right. And then for the downside, that will be the negative side. So we have negative 1, negative 2. Right, let's move it up a little bit. You can have negative 3 here. And then for this side, we have the negative of the x. So we have negative 1, negative 2, then negative 3. Right, so one of the things you are supposed to do is that you are supposed to draw a line at y is equal to 4. So our y is equal to 4 is here. So we'll draw a line at y is equal to 4. So let's use a black for the lines. So y is equal to 4. We put a line at y is equal to 4. Right, so that is part of what has been given to us, right? And then we also have our point. So one of the points will be negative 2, right? 0 and negative 2. So 0 on the x-axis, negative 2 on the y-axis. So that point is right here. Let's put the point here. And then we'll label it as 0, negative 2. And then we also got 3 and 0. So 3 on the x-axis and then 0 on the y-axis, right? So we have 3 and 0. Then we'll draw a line to pass through those 2 points, right? So that's also right. So the line passes through here. So the line touches the y is equal to 4 at this point, right? And then it also includes the x-axis. So it means that we can as well put a line here, right? So that we distinguish where we are finding the area at. So we are finding the area at this side as well, which is the x-axis. And then the area bounded by the y-axis, which is this side as well. Right. So we need to get our line well. Okay. Okay. So the line is going to be here, right, as well. With technology, you have to be quite careful where you put the line. Okay, so it's supposed to be here. So we want to find the area, right? We could call this side A, B, and then C and D. So we see that this forms the shape of a trapezium, right? So we have the parallel sides. We can say the parallel sides can be A and D, and another parallel sides can be B and C, right? And then we have the height, which for that height, we can say that the height will exist here, right? The height will be here. So let's call that height from D to O, right? So the height DO is the same as A to B, right? So we have the height D to O, right? So we know that to find the area will be equal to half the sum of the parallel sides. So the parallel side is A to D, and then plus B to C, which is from this side to this side. These are the parallel sides, right? Multiplying the height, which is from D to O. Now, we know that from A to D, if we check it very well, it is from 0 to 3. So that is 3. And then from B to C, it is from 0 to 8.5. So that is 8.5. And then we have D to O, which is from 0 to 4. So that is 4. So therefore, we can probably determine the area as area to be equal to half. The A to D is 3, plus the B to C is 8.5, multiplying the D to O, which is 4. Right, so we know that this gives us half. 8.5 plus 3 gives us 11.5. Then we multiply this by 4. Right, 2 can go here 1, 2 can go here 2. So you are going to have 11.5 multiplying 4, and 11.5 times 4, right, times 2, multiplying 2 because we've cancelled already, is going to give us 23, right? So you are going to have 23 for the multiplication of half multiplying 11.5 times 4, right? So that gives us 23. So it means that the area, right, is equal to 23 square units. So we've gone through the process by being able to draw the graph of the function. We've drawn the graph of the function for the line that have been given to us, the different lines that have been given to us, the x-axis, the y-axis, and then the line that have been given to us. And based on that, we've been able to see that the shape is a trapezium. And using the shape, we've been able to find the area by using the area of the trapezium, which is half multiplying the sum of the parallel sides, multiplying the height. So in our next lesson, we want to consider how we can actually be able to find the area of parabolas. So we are going to look at parabolas in general. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.